Hey guys, my name is Aileen Holbrook, and this is my brand new channel for YouTube, Redox Alchemist. In this series, we're going to explore chemistry through experiments with many different elements and compounds. For our first experiment, we are going to use hydrogen gas and a water bottle to blow up a watermelon. Now let me first start by saying that this experiment can be potentially dangerous. Hydrogen gas is extremely flammable and can explode if built up over time and kept under pressure. For your safety, please do this in an open area, away from any open flames or electrical outlets. For the first part of this experiment, we're going to need a 250 milliliter Erlenmeyer flask. Next, we're going to need 100 milliliters of muriatic acid, or better known as hydrochloric acid. This can easily be purchased at Home Depot or any other hardware store. HCl is an extremely corrosive acid, so eye and skin protection are needed. I'm going to add in another disclaimer. During the recording of this video, my first attempt at this experiment was a failure due to too much HCl and aluminum scraps. This produced a large amount of H2 gas at an extremely fast rate. I have purposely kept the footage in the video to show the consequence of adding too much of the reactants. I recommend using 50 milliliters of HCl and adding 30 milliliters of water to dilute the solution. This should lower the reactivity and give more time to back away from the blast site. Next, we're going to need a sheet of aluminum foil, which can easily be found in most kitchens. For the failed experiment, I used a 2-foot aluminum sheet and then ripped 3/4 of it into small pieces to increase surface area. I suggest using less than half of the 2-foot sheet, probably about a quarter of it. Aluminum foil has a thin layer of aluminum oxide protecting the sheet, making it difficult to react with other chemicals. By increasing the surface area of the foil, you increase the reactivity of the experiment. Now for the water bottle, it should be a regular sized plastic bottle with a volume of about 500 milliliters. The volume may differ with other brands, but they should all be around the same number. All the water should be emptied out, and the outer label should be removed. Now, let's look at the chemistry behind this experiment. The aluminum scraps that we place inside the water bottle will react with the hydrochloric acid to produce H2 gas and aluminum chloride. The balanced equation below represents a single replacement reaction, where the aluminum and hydrogen trade places. This reaction is also categorized as a redox reaction, where electrons are exchanged throughout the reaction. The aluminum is being oxidized as it loses electrons, and the hydrogen is being reduced by gaining electrons. The balanced equation below represents the number of electrons exchanged throughout the system, followed by their half reactions of each individual element. Now, let's talk about what actually causes the watermelon to explode. Once all the scraps have been added, HCl will be poured into the bottle to react with the aluminum. Like we said earlier, this produces H2 gas inside the bottle. Now remember, I'm not actually igniting the gas or any other chemical in this experiment. What happens is that I actually close the bottle as the reaction occurs inside. Eventually, H2 gas will cause the plastic of the bottle to expand and then eventually explode. Our chemicals are ready for the apparatus, but we're forgetting one minor detail. We'll put aside our water bottle and HCl to show off our test subject. Now by that, I mean the melon. While many people have used other fruits for this, I prefer the watermelon for its size. It doesn't have to be the biggest size possible, but it has to be fresh and not rotten. If the melon is rotted, it becomes too soft and will absorb the shock of the blast. As you can see, I've cut a hole into the melon at the top and have taken out the inside fruit. By doing this, I've created a hollow space within the melon that can fit the water bottle completely inside. Now that everything is ready, we're going to transport the melon to the tarp and get ready to go. Just as a reminder, the footage you're about to see in a minute is the failed attempt. This setup has 100 milliliters of HCl reacting with a full 2-foot aluminum sheet. Please do not attempt to do the experiment this way. You may injure yourself or others around you. The watermelon actually has a purpose in this experiment. Besides being the test subject, it also helps to lower the sound of the explosion by being turned upside down to cover the bottle. You'll see in a moment that the reaction is so fast and exothermic that I'm unable to turn the melon over. This reaction can get very, very hot. In fact, it's so exothermic you could actually see the steam rising out of the bottle, along with the H2 gas. I could barely hold the bottle up in my hand, it was so hot. That's hot. Shoot. That blast may sound tolerable from the video, but in reality, this blast sounded like a gunshot. It was so loud, my neighbors heard it from inside their house. Lucky for me, I have kind and forgiving neighbors. Now that I've turned the melon over this time, we can expect a much quieter blast. This footage is the successful attempt with 50 milliliters of HCl diluted with 30 milliliters of water with a quarter sheet of aluminum foil. As you'll see, this reaction isn't as violent as the first. I've purposely kept the footage in to show how much time it takes for the blast to occur. Unfortunately, my voice may overpower the blast. I was unable to edit myself out, but the footage is still pretty good. You may also hear another voice in the footage. My grandfather, who has been a chemical engineer since the 50s, was helping me conduct this experiment. So for now, I'll just have to let you see what happened for yourself. Enjoy! Got it, there we go.
You got it. It blew it apart.
Thank you guys so much for watching this. I really enjoyed doing this for all of you. Please subscribe to us, like us, and comment if you want. Next week we'll be trying to take on sodium, one of my favorite elements of all time. Thanks a lot, guys. See you soon.